There we go. All right, so thanks. So I'm going to take a little bit of a global perspective. And 25 years ago, or a quarter century ago, the United Nations got together and talked about sustainable development on a global scale. They defined it as development that meets the needs of the present without compromising the ability of future generations to meet their needs. And there's really two key components to think about when we think about energy. The first is you need a minimum level of development to ensure a minimum quality of life. And by that, I mean you need to have a minimum level of development that people can meet their basic life needs: heating their home, access to health care, access to food, access to education. But at the same time, there's a maximum level of development where we begin to exceed the Earth's life support systems, and particularly the ability of those systems to supply us with the services and products we need. Now, this report also identified climate change as the single greatest threat to both of these, both the rights of the poorest of the world to get that minimum level of development and the biggest threat to the Earth's life support system, quarter century ago. And this report also, for the first time, made that link between access to modern energy and sustainable development. And this graph really drives this home, where you see the blue line. And what you see is there's a threshold amount of energy that you need to get that minimum quality of life. This is the Human Development Index, a measure of quality of life. To get to about 0.8 to meet that minimum quality of life, you need about 2,000 kilowatt hours per person per year. Above that threshold, you don't see any gains. You can look at the United States and the United Kingdom. We use twice as much energy as them, and we have the same quality of life. That drives home the importance of conservation and efficiency. But the thing to keep in mind is these green dots are the 31 developing nations of the world. They use an average of about 1,000 kilowatt hours per person. The United States uses 8,000 kilowatt hours per person. So for the poorest and developing nations, which include over 100 nations that don't even make this graph because their quality of life is less than 0.3 on this index, their sustainability gains are accessing modern energy. Right now, that's going to be fossil fuels, unless we provide them with renewables. And for the developed nations, they need to do energy efficiency and conservation to reduce their consumption. And it's remarkable, it's almost 2 decades to the day that this 12-year-old really laid down the gauntlet in terms of what it means in terms of our moral obligation for both sustainable development and dealing with climate change. And her 7-minute speech is remarkable if you haven't listened to it. Here's her final quote, though. In school, you teach us how to fight, not fight with others, to work things out, to respect others, to clean up our mess, to not hurt other creatures, to share, to not be greedy. Then why do you go out and do the things you tell us not to do? You grown-ups, you say you love us, but I challenge you, please, to make your actions reflect your words. Now, since that speech, there's been tens to hundreds of international conventions, accords, you name it, trying to deal with this. But really, there's 3 moral principles behind all of these international agreements. The first one is an environmental one. We simply must stabilize carbon dioxide and the increase in temperature from global warming to a level that avoids dangerous climate change and allows these poorest nations of the world to reach those minimum levels of development. The second one you can call an equity or justice criteria, and that is that the nations and every generation has to take responsibility for not only the current emissions, but their future emissions, and really limit climate change to something that we can deal with. And the final one is really what I call the adaptation criteria, and that's that the nations that are most responsible for the crisis we're in, the United States, the European Union, and China, to make sure we provide those vulnerable nations the resources they need. Now, this graph really, so what's our progress? This weekend, the next Earth Summit started. So what progress have we made in the last 2 decades? Remember, the poorest 130 nations in the world aren't even on this graph. And what you see, this graph has Human Development Index going along this index. So that minimum quality of life. Remember, To have that minimum quality of life, you need to be on this side. This is where the European Union and the United States are. At the same time, you can't exceed this ecological footprint. Under this game, if you're above 2, you're exceeding the Earth's life support systems. So the sustainability quadrant is here. There's only one country that's in there, and you can't see it. It's Costa Rica. Where do they get most of their energy from? Hydropower, 85% of it. And the take-home message is, until renewables are conventional, we can't get to that quadrant. There's simply no way, because you need that minimum access to energy, and right now it's fossil fuel dominated. And when you look at that ecological footprint, 80% of those impacts are from fossil fuels as a source of energy. Impacts on water resources, impacts on air and water quality, stable climate. You name it, they're the impacts. So this is where we're heading as long as renewables remain non-conventional. These are the Intergovernmental Panel on Climate Change projections. The upper ones are their worst case projections in the year 2000. The bottom ones are their best case projections. Global emissions are tracking the worst case scenarios. In 2010, we had the highest annual increase in carbon emissions ever. 2011, we were a little bit better. We were only the 4th highest. Until we get renewables conventional, we're going to end up here, where this study showed. 80% of the power plants that are going to be operating in the year 2020 are already built or under construction. We have locked in those emissions. But when viewed from the lens of as a moral issue, view sustainable development and climate change from a moral perspective. And from a policy perspective, you've got to mitigate plausible worst-case scenarios. And in the last 5 years, there's been a remarkable amount of research trying to figure out, well, what are those worst-case scenarios? And tipping points are one I want to highlight. Tipping points are when we have a small change in a forcing agent, in this term, global warming or human-induced warming, that triggers an abrupt change in the Earth's climate system that causes a system to change states. And once you change states, from humans' perspective, they're irreversible. The best example I can give you is one playing out right now. The Arctic Ocean in the summer with ice, and the Arctic Sea without ice. We're not going back once we get there. And this study looked at a whole host of them, but 2 to highlight is, here's the Arctic sea ice. So there's a high probability we're going to cross this tipping point. But the magnitude of impacts for humanity are low because we don't rise sea level. You don't increase sea level when the Arctic sea ice melts. Pay attention to the second most likely one we're going to trigger. Loss of the Greenland ice sheets. High consequences for humanity because of the sea level rise. So where are we heading as long as renewables remain non-conventional? So here's the Copenhagen Agreement. There's a lot on this graph. The only thing you need to pay attention is the location of this rectangle, the bottom. This is the best case scenario. Every single commitment from every single nation that's been made under Copenhagen or any other agreement, it assumes they're all implemented as fast as possible. And remember, 2 degrees is where we've agreed that we need to limit warming to 2 degrees to avoid dangerous climate change. Best case, we have no chance at 2 degrees. We have like a 60% chance of exceeding 3, and their best guess is we're heading from 2.4 to 4 degrees warming by the end of the century. That's because renewables remain non-conventional under these commitments the nations of the world have made. And to really drive home from a policy perspective of why it's critical that renewables become conventional by the year 2020 is this graph. These are the tipping elements here, and this is how much warming we need before we start risk tipping them, crossing them. The cool thing to notice is, we've already locked in, we're warmed by 0.8 degrees. We've already committed to about 1.3 degrees of warming because the ocean's inertia. This is where we're heading, assuming we do everything we said under Copenhagen. You'll notice the Arctic sea ice one isn't on this graph. These authors argue we've already crossed that tipping point. We're done. The next one to worry about is the Greenland ice sheet. We definitely risk crossing that. And that's when we don't have renewables on a big scale. So This graph really drives home the intra-generational issue. That is, the equity and fairness issues between nations. On the top of this graph, the redder you are, the more responsible you are for the current climate crisis we face. On the bottom of this graph, the more red you are, the more vulnerable you are to climate change. That's one, because you're either really vulnerable to climate change impacts because you have a coastline, or you're simply so poor you don't have the resources to adopt. The take-home message is that the countries that are most responsible are going to be the best off under climate change. And the flip side, those countries that are least responsible for climate change, the poorest nations, are going to bear the brunt of the impacts. When renewables are conventional, basically the developed nations of the world and China will have met their moral obligation. First and foremost, by keeping and reducing their per capita emissions to levels that avoid dangerous climate change. The second thing is those nations are going to have to deploy technologies to the world's poorest nations to help them mitigate climate change, and at the same time, pull themselves out of poverty. 130 plus nations are called the poorest nations of the world. And finally, for those countries that are really in it for the long haul, we're going to have to fund adaptation in some of these countries that are most vulnerable. But what about intergenerational? This graph really drives home the intergenerational issues we face. But keep the scale on the bottom in mind. This is over a 1,000-year scale. Here's the graph we just talked about. We're going up through the roof, global emissions per year. Up, up, up. They need to peak quick. And what you see is even after we peak emissions and we start to reduce emissions, as renewables become conventional, carbon dioxide levels in the atmosphere and the temperature continue to rise and finally stabilize a couple hundred years later. Future generations are stuck with that temperature increase for the next 1,000 years at least. Same thing is the loss of the ice sheets. These blue lines show the rising sea levels. So even once we stabilize the situation, sea levels are going to continue to rise for generations and generations. So when renewables are conventional, all the nations of the world in this generation will have met their moral responsibility to future generations by doing their best to limit where this red number is, that red line. Because we've got to limit that temperature increase to avoid crossing those tipping points. Because if we cross those tipping points, future generations really are going to have no control over where climate's heading. It'll dwarf their ability to reduce emissions. The other thing I'll drive home in terms of how fast we need to do it, 2020 would be great. I think conservation and efficiency will have to buy us time, as one of the previous speakers said. We have to limit the area under that curve. And if we don't peak soon, we're going to make it next to impossible for future generations to make those reductions they need. And finally, I just want to come back to this graph. Once we get there and renewables are conventional, the developed nations of the world, through efficiency and conservation renewables, will head down to the sustainability area by reducing their footprint. The emerging countries of the world will make that transition to modern societies, China, India, without exceeding the Earth's carrying capacity. And really, the poorest nations of the world will start to move where they improve their quality of life without exceeding that carrying capacity of the Earth. But finally, when renewables are conventional, we will have finally made our actions reflect our words. And will become the change we want to see in the world. So with that, thanks.